Good morning, everyone. Welcome to this session. So we are going to speak about waste heat recovery, industrial waste heat recovery in the food segment, and why we believe this is the silver bullet to the decarbonization of the food sector. Armstrong is a family-owned 125-year-old company. We are run by the fifth generation of the Armstrong family. We're a global company. We have 15 facilities around the world, more than 3,000 employees. And for more than a century, we've been working in steam and condensate system, which is what is being used today in food industry in order to transfer heat from a central location, a gas boiler, to the process. Originally, we have started with a component in the steam system called steam traps, something which is part of the maintenance of the plant, like steam leaks, like insulation, something that needs to be fixed on a regular basis, and which brings some energy saving. If it's not taken care of, it can generate some energy losses. Then progressively over time, we started looking at energy efficiency of the whole steam and condensate loop. So we zoomed out and we look at condensate recovery, flash steam, and the potential for optimizing the whole steam and condensate system. But that was still a kind of single-digit saving. As our clients decided to go further in their CO2 savings and energy savings, we started looking at de-steaming. De-steaming is the replacement of steam by hot water for low temperature points. So using steam below 100 degrees is actually technically quite challenging. So de-steaming of the hot water production or applications such as humidification allows to gain more significant energy efficiency of more than 10%. Then we crossed the mirror. We were on the utility side, and we went on the other side of the process and started looking at industrial waste heat. When you look at the industrial waste heat, the quickest win is high temperature heat. If there is a temperature stream at 200, 250 degrees C, you can recover this just using a heat exchanger that's called direct heat recovery. But that just brings you so far. With all these steps in steam and condensate improvement, de-steaming, direct heat recovery, you can recover maybe 30%, or you can save 30% of the primary energy. If you want to go beyond that, we need to leverage low-grade heat, and that's where heat pumps come in. The heat pump can be the big changer, allowing to recover this low-grade heat, upgrading it to the high temperature that the process needs. So we put together a design concept that we call circular thermal. This is about applying circularity to heat. This is involving several steps: pinch methodology for the audits, direct heat recovery, low-grade heat recovery, and heat pumps. And we have the ambition to scale up heat pump around the globe. We don't have the technology in-house, so we partnered with a company called Combitherm, based in Germany, in Stuttgart. And we are currently scaling up the deployment of heat pumps in North America, in the US, in Asia, China, in India, and also in Europe, in our Belgian factories. So what is circular thermal? Since the Industrial Revolution, we have been designing industrial heat system in a one way. We were putting gas on one side, burning that gas in a steam system, which have some inefficiency. So about 20% of the energy in the natural gas is going to be lost before it even reached the process. Then 80% of the energy is going to go to the process, but very small part of that energy goes actually in the product. Very few products are heated. Some products have chemical reactions, but most of the energy is actually going to be wasted as radiation losses and is going to go away through the stack of the process. Applying circularity to heat, like we do for material and we do for water, allows to significantly change the game. We can just run now on electricity, but not one-to-one electricity to gas ratio. We can run with only 20% of the equivalent energy in electricity. How do we do that? We put a heat pump with this steam, and we recover the stack, applying circularity to the process. Here is a practical example from the company Gelen Counterflow. Sander Gelen, the owner of the company, is here. They are down in 10.1. You can go and talk to them. So they were really revolutionary, applying this technology with our partner Combitherm into pet food dryers or aquafeed dryers with a vertical counterflow technology. The principle is the one I just showed you. So the recovery of the exhaust air, the condensation of the air. So we want to get the latent heat. We don't want just to stay in sensible heat territory. We need the energy in the latent heat. So we need to condense the stack. And then this energy is now hot water and can be stored and used and upgraded by the heat pump, which then goes up to 120 degrees and allows to dry the product again and heat the air. This has been applied in multiple projects around the globe. One of the most public one, and the video I'm going to show is actually on YouTube, is with Cargill in Norway. It is a 3.3 megawatt installation. What you see on the screen are 4 heat pumps. So each one of these heat pumps is about 1 megawatt. They have multiple compressors, so 3.3 megawatt thermal installation. And it has been installed in this plant, which is making fish food, aqua feed. So this is the size of the plant. The vertical side is the dryer. So it is, I think, one of the largest, probably the largest dryer in this category. And they do this fish feed for salmon farms, which are there in Norway. So this project has allowed to reduce significantly the CO2 emissions by more than 3,000 tons of CO2 per year by applying the circularity on heat. So this is the actual installation, and you're seeing these are the heat pumps with the hot water tanks around, and this is the dryer, which is using the heat pumps. The secret there is to use different temperature at different stages of the drying process, so it is possible to recover the energy in a more efficient way and improve the coefficient of performance. So this is how it's done for a single application. Now, applying this principle to a whole plant becomes more difficult, but another significant source of waste heat is actually the cooling system. Cooling is about taking heat out, so all the plants which are cooling or they actually go into freezing, such as ice cream, frozen food, they have a significant quantity of waste heat going to the cooling towers, which can be recovered and leveraged. So putting together sources from the cooling towers, which by the way decreases also the water consumption of the plant, and the heat from the process allows to create a more efficient system, but then comes the challenges of batch processing and storage of the energy. So extracting the heat from the cooling, de-steaming, using the direct heat recovery and the low-grade heat recovery together with heat pumps create this circular thermal system. So it is important to understand that we do not change the process. We just change the way the energy is delivered to the process. And instead of having this one-way system, we just make it circular and we decrease significantly the amount of primary energy. We don't ask for any changes on the process side. This thermal integration is achieved using a process called pinch methodology. Pinch has been developed during the 70s and the 80s in the chemical industry. It is running very well. That's why the heavy industry is actually more energy efficient. It is running very well for constant processes. We took the challenge to apply pinch to batch processes in the food industry. So pinch is about identifying what is heated and what is cooled in a plant, identifying these heating and cooling streams and overlapping them, identifying the gray zone, which is direct heat recovery. You just need a heat exchanger. And then we don't want to get the high temperature heat and bring in below pinch temperature, because if we do that, we would need more heating and more cooling. It's not productive. What we really want to do is do direct heat recovery first, and then the heat pump, they do the dirty job. They recover the lowest temperature heat in order to bring it to the highest temperature which is needed and which cannot be achieved with direct heat recovery. Now, many people look just at the outside. They look at the steam temperature and they tell us we need 180-degree heat pump. The reality is that we need to go beyond this black box, as it call it in pinch methodology. We need to go in and look at the temperature in the heat exchanger. And often the 180-degree distribution, actually it's 120 in the heat exchanger. But then we also need to look at the other side of the heat exchanger. So steam is used at 120 degrees to heat sometimes products at 70 degrees C. If you want to make this system energy efficient, we have to minimize this temperature lift. That's the secret of the efficiency of heat pump, is minimizing the lift. That's improving the COP. So opening the black box and the white box. Then for certain applications, steam is needed, and generating low pressure steam at about 1 bar brings us again in steam territory. And then compressing that steam with an MVR system, with a steam compressor, actually is probably the most efficient way. These steam compressors are relatively efficient. So that creates a secondary loop, which is not an open loop, it's a closed loop. They are heat exchanger, condensate, and flash steam. And this is where we are back to our core knowledge of our first century, is how do we make this loop efficient. So that's an example of a heat pump generating steam in a secondary loop in our demo bench. So that's the secret of heat pumps: minimizing the temperature lift, recovering the warmest source, decreasing the sink temperature. And obviously, the deployment of heat pump is also helped by de-steaming, by the integration of the system, and also carbon taxes beyond the decarbonization goal. And certain companies now cannot look at steam anymore. So this is how a decarbonization roadmap look like: recovering, de-steaming, recovering direct heat, deploying heat pumps. And then, if that's not enough, often it is enough, but if it is not enough, biogas, hydrogen, biomass, direct electrification might allow to bridge the gap in the end. For those of you who are interested, we have a summary in a white paper that we can distribute at the end, and I'm going to pass it to the second speaker.
Thank you for the invitation to this fair. My approach is not a product or technology approach. My product is my presentation is a strategic approach to the decarbonization and climate neutrality. First of all, who is ENGIE? ENGIE is a worldwide company located in France and Paris. We have over 100,000 employees worldwide and a revenue of more than 90 billion. And our goal is to reduce the CO2 footprint. And at the moment, we have installed 38 gigawatts worldwide. And our goal is to reach 80 gigawatts by 2030 with renewables generation capacity. In Germany, we have over 5,000 employees with a revenue of 1.6 billion, and we are in reach of our customer with more than 50 branches. We get the sustainability rating, the gold medal from EcoVadis. And what is the situation? A lot of industries, companies had set climate neutrality goals, but how is to reach these goals? How is the path to it? And we say we have a new energy trilemma with three challenges which we should have a solution simultaneously. First of all, it's a sustainable transformation. Important is also that we involve and motivate the employees to focus on the sustainability transformation. The normal goal of a company is economic and risk management. Cost efficiency is every time the number one, but to create value creation and risk minimization is one of the second trilemma we see. And more with war in Ukraine, we have the energy supply security and how can we constant supply with energy. So the questions we often get from our clients are, how do you position yourself for the future? How can you cope with the complexity with neglecting your core business and investment and operation? What does it cost me to act towards climate neutrality? It's cheaper or it's expensive, but the question is, what does it cost when I don't act? And the last question we get very often is, what to do when framework conditions change, and that's the situation in Germany with the politics and regulatory situation. So the question of a lot of clients in the industry is, shall I make decarbonization alone or as a partnership? And if you see the drivers, the 9 drivers, I will pick some, the cost pressures, the ESG requirements, a very important topic, and increasingly complex and strict regulation. So for our clients, we are the partner who are not delivering energy as a commodity. We have an energy strategy. so that it is a long-term partnership. And the long-term partnership leads me to the next slide. That means we are for the full value chain responsible. We are starting with consulting. With a client, we have an artificial intelligence-based prosumer tool where we look at the processes, the energy processes of the clients. Where can they increase their energy efficiency? Where can they reduce their carbon footprint? And we have some business models. We make several scenarios to reach their goals in 2030 or in 2040, whatever the goals are. The next step is on the results of this prosumer strategy is to design solution with clear performance commitments we will take in. Then the financing of the assets, we will deliver the implementation. That's normal for every industrial climate, but we are also responsible for the operation and maintenance of this asset over 10 or 20 years, so that a client can say it's total value chain processing solutions we will deliver. It's a holistic approach. What is the advantages of this is the utility as a service, that we have the ownership, the risk, and the control of the energy generation. We design plans, build, operate, and maintain the infrastructure. That's the difference to an EPC company. And no investment for the customer. He has no problems with investments. He can focus on his core business. And we are responsible for the system availability over the 15 years, and that's our risk, so the customer can focus on their core business. The advantages is that we transfer the operating and maintenance risk to ENGIE. The clients doesn't have this risk. We procure the fuels and markets from the energy generated. We are strong regulatory expertise for ESG, KVK subsidies, very important for the industry. Also to cost optimize the personal concepts, and in a lot of cases we have also the possibility to transfer personnel from the client to our staff. And we have an economic optimization of the system operation during the ongoing operation. So we can say the client can concentrate on his core business, and we are for the focus on the energy and strategy. So the result is climate neutrality is a strategic decision. That's very important. Professional for professional said one client to me, it's a strategic partnership for energy and climate, so that a client can focus on their core business. It's a decision on the C-level. We have a lot of discussion with the CEOs and CFOs. So it's a long way to make this decision. But the result is that we will be the right partner on the way to the goal, a long-term partner, and becomes part of the corporate strategy for energy and climate, and enables our clients to concentrate on their core business. Thank you very much.
Hi, actually, thanks for the invite to speak today, and it was great to hear the two previous speakers, very incisive, and we probably actually fit in between them. So look, it's a huge area across the world. Decarbonisation, industrial heat is probably the quickest win that governments can do and societies can do to decarbon. So I'll quickly go through. We're based in Ireland, although we've projects in India and in Europe as well, but we're based in Ireland. So I've been involved in the energy sector for actually many years. This is my 8th startup, so I'm really, really enjoying it. We started in COVID, and we've grown the business very successfully over the last couple of years. There's an overview of some of our clients. So we work in the food and dairy, we work in the pharmaceutical, and all industry that uses heat and power. That's where our targets are. The decarbonisation journey, well, it starts for us to look at technologies. And today I'm going to speak about high temperature heat pumps, but obviously MVR, as my colleague spoke about, thermal storage is a huge part of heat pump technology. There's some really interesting technologies that are coming out where we can store really high grade heat at 1500 degrees when we've excess electrical power on the grid. And these are all the future things that are coming. Battery storage, again, technologies come down a lot. Solar and biofuel is another area where we see. So heat pumps, again, as a lot of people are aware here, heat pumps, historically, we were up at 60, 70 degrees. Now, this technology is available, it's operating, it's mature at these type of temperatures and above, maybe up to 160 degrees as well. Again, it was described earlier, but we look at all this lovely waste heat from chillers and from cooling towers and compressors, exhaust, water treatment, and we basically put that through and we use it then to hot water, dryers, CIP, steam, and thing. So it's the integration of these heat pumps is really important. And again, we've seen this slide before. I think one of you guys were copying my slides, you know. But again, it's this concept of, before it was a linear, we brought in steam boilers, and somewhere along the process, all that heat was wasted. This concept of the circular heat, where we bring it in, we circle around us, gives us our efficiencies. So I suppose to get into the practical examples then, so this is a project that has got a lot of publicity. It's whether it's the first time, we're told by the European Heat Pump Association, it's the first time a distillery globally hasn't put any gas boilers. So there's no gas boilers on this. It's a new distillery. It's operating now. We produce the water at 120 degrees. It's a pressurized water. And we take the water back from the process at 60 degrees. But when you think about the distillation process, you know, we distill and then we condense. So it's a really good application for heat pumps. The COP in this is about 4.2, so it's a very good COP, even at these type of lifts. It's very good economically for the client. In Ireland, our spark gap is about 3.5, 3.7. So we have to hit COPs above 4 to make economic. So we're very targeting that. So there's a bit of an overview of it. Again, thermal storage, kind of heat pump. In this particular case, we used kind of Olean, but we are kind of agnostic when it comes to technologies and that. But there's the key parameters for us engineers, but the COP in heating, cooling, general, and that's the energy saves on it. Next, a very quick, very simplistic drawing, but we're producing high-grade heat. We have a cascade on the heat pumps, which gives efficiency, produce hot water, and then the source water comes back as well. And that's a very overview process. These are applications. So these are applications that are installed, they're operating, and it's giving customers, especially end users, this level of comfort that this can work. So here's a 4 megawatt project for, again, a very large distillery in the Irish market. Again, very standard temperatures, 90, 30 and source. But again, you can kind of see 6,000 ton. That's equivalent to probably retrofitting, I don't know, 6,000 or 7,000 homes in Ireland. So it's very good bang for our governments to invest in. We do all the in-house design. We try to produce a lot of stuff off-site fabrication due to cost implications and quality. So this is just a very quick 3D modeling. That's the 3D modeling we have done right the way through. And then we get into, that's the actual producer, and that's the units dropping in. And the great thing about this is we can commission these. A 4 megawatt system will be on site and fully commissioned within about 2.5 months. And that's where we need to be. We need to drive costs out of this market. Everything I get from clients is about cost. But, you know, all of a sudden, most of our projects are sub 3-year paybacks. So cost is not. Dairy sector, here's a project that's going into procurement at this moment. It's a 9 megawatt project. And it's a really interesting project because this is a dryer, as Sandra will know about dryers and that, but this needs 210 degrees. So originally we were told, well, heat pumps aren't applicable. But as we know, it's all about the different grades of heat. But we're degassing this project by 51%, which again is a huge 10,000 tons of gas. And it's economic. It's very economic for the client. And there's the size of the plant, just to show you the scale of the dryers we have. There's a 5-story lift to go up to this dryer. So these are not small scale. And the dryers, there's different dryers. There's a very process overview, the way we're looking at it. And then, we're picking up the pasteurizers, evaporators, but we're also pre-drying the air going into the dryers very efficiently here. So they're all the parts of this, and that gives us this 51% degas. And again, look, we blend electrical generation as a bit like ENGIE. It's very important because why? Because it brings down the spark gap. So this is a client of ours. This is a 5 megawatt solar. We're about to double down on that now, put another 5 meg. We bring that into the factory. We're putting heat pumps in, and all of a sudden you have a very turnkey solution. And, if need be, we can give a 25-year heat rate, which you think. But it's to blend this when we have that spark gap. Obviously, in the future, the market's going to be solved. The market's going to solve the spark gap. But for the next 10 years, anything we can do to accelerate that, we do. There's rooftop, which we do. That's a 40 megawatt project. We have a 100 megawatt project going into planning at the moment. This is the scale that industry needs to drive this out. And then we also track technologies where we are on our carbon emissions and that, and we can activate control systems and that to, once this technology is going in, we can utilize it when there is low emissions. Low emissions means low cost. That's what it means on pricing. There's a typical curve, 24th of January. So you can see in the middle of the night, we had electricity costing 1 cent versus 28 cents. So this is, again, very familiar with so it's just, this needs to happen. This is not rocket science. This is technologies we're just deploying, and we need to educate clients, and we need to roll this technology out. Thank you. There we go.
Thank you so much.
Yeah, okay, we will, yeah.
For those interesting presentation.
Oh, yeah.
To know more about these technologies, such as heat pumps, devices, and thermal circular innovations. So thank you for being here. I think it's fascinating. For me, I'm not from the industry. I think I have learned a lot in the last days. And, well, let's move on to the discussion. We don't have enough time. And it will be also great to have a couple of minutes for questions or comments, at least one question. Well, today I had a glass of milk, and which got me thinking how important is the amount of resources we use to produce food, and how important is the food and drink sector to lead this transition and towards a more sustainable world, a more sustainable future. So I would like to ask a general question first, and then we can go more specific. But we are here at Anuga Food Technology Fairtrade to answer those questions and doubts and to share insights also and to inspire, because this is a stage for innovation. So my first question is, what challenge do you face spreading these technologies such as heat pumps, circular thermal innovations across Europe? And what are the main concerns you get from your customers when they attempt to deploy these technologies? So who would like to start?
Okay, so the main challenge for me still is awareness. That's why we're here. That's why we try to share this information beyond the energy experts. We all agree about what was just presented, but this remains a very expert world. So creating awareness at the highest level, at the C-level in business companies, at policymakers, I think, is the key. And we start to get there. We start to understand that circularity is the answer to heat, as it is the answer to materials and water. The second challenge is the economics. COP, coefficient of performance, is fighting with the electricity to gas price. That's why we need to use storage and we need to leverage this low price during certain moments of the day. But there is an increasing awareness that we need to shift taxes from electricity to gas or to other fossil fuels and reduce this electricity to gas price from 3 or 4 today down to 2. European Heat Pump Association is very big on that. And in certain Nordic countries, we see electricity to gas price of 1, and sometimes actually gas is more expensive than electricity. That's the reason why the Scandinavian countries are electrifying, is the price. They love, of course, sustainability, but it is very economic. So that's going to be, I think, the challenge for the next 5 to 10 years, is to make it economic for the companies to invest and go into this decrease of energy consumption.
Yeah, and I'd agree there. Like, awareness is the biggest area. And so how do we increase their awareness? I think as companies and as the experts, we probably need to take some risk. So that distillery project, that was a huge risk. We had to carry that full project economically and carry the full warranty on it until it worked. So we had to integrate with process and utilities, which is a really interesting area. But now the great thing about it is that project is working now. We have 8 distilleries on our cards at the moment. The big companies in this sector now are beginning to say, well, hang on now, this little distillery, they can do it. And so I do think there's a bit of coordination, be that through grant process, but sometimes it can be too long, right? So we just did the project. We understood as engineers, there's not a risk. That's our risk. We understood that. And we took that and we delivered that project. That milk project we're doing is really interesting because that's a retrofit into a huge, and again, we're having to carry a fair bit of risk on that. But it's a great project. So I think that combined with the spark gap is, I agree, there needs to be a change in the taxes and that. But obviously that's going to come. You know, in the Irish market, we're due to go to 80% renewable power, 80%. So we know in the future that spark gap is going to narrow. So that's good for us. I'm also the chairman of eHeat Ireland, which is a electrification of industry heat. So rather than the Heat Pump Association, it's kind of a subset of that. And it's really for industry to speak to governments. And we lobbied for grants, and the grants are linked to the COP. So the COP of 4 gets a 40% grant. The COP of 2 gets a 20% grant. Now that's really smart because obviously then a COP of 4 is more expensive to do. But obviously from the country and the customer, it's much better to do. And that's working extremely well. And little nuggets or areas that are working in one jurisdiction should look to whoever, rather than giving a flat grant. Because a flat grant, you're competing against air source heat pumps. We're going, well, that's not good. You know, and that's what we did. And that was really successful. We lobbied for that, and that's in now. So things like that, I think maybe a bit of coordination, because it's cottage enough industry compared to gas boilers and compared to industry. So there's maybe a bit of more coordination. Sorry.
Yeah, it's okay.
I think decarbonization is a journey, and there are 2 drivers for our clients. Let me explain an example. It's Milupa. It's a part of the Danone company worldwide, and we have a decarbonization roadmap with Danone. And for this German site in Fulda, Milupa, we have a roadmap to decarbonize this site. We delivered since 10 years steam, cool, air pressure, and so on. And the main drivers are from the B2C market. It's the B2C market, the food and beverage. More and more clients said we want to have climate neutral products. And the other one is the financing situation of the CFO. He gets the money less expensive if he has a good story of his decarbonization. And so I think that's the 2 drivers, and to leverage the decarbonization. It's not an economic, it's an economic situation for the C-level.
Yeah. And for sure, yeah, to raise awareness is a big issue, it's a big concern. And you work with customers from small and big companies. And how it works inside the companies in terms of knowledge, sustainability knowledge. Do you know, like, there is like a chief, or they count, for example, with that department of an Abteilung in sustainability? What is your experience? Because you already show some case studies, and it will be interesting to know more about it.
From my point of view, if we have the discussions with the technical directors, they have very good experience in gas technologies and so on, gas boilers. But to decarbonize with biomass or with a geothermal technology, they don't have the experience. And now they have to decide, we have to get this knowledge and the experts in a situation where the war of talents is increasing more and more, or we have to find a partner who has this knowledge and he can support us in this new technologies.
Yeah, there are sustainability departments which are the gatekeepers. They qualify the technology, but then we have the process people, and there is a lot of conservatism there. There's some scare and fear to change the process and impact the product quality, which obviously is a big danger for them. But I never seen the people in the industry so open-minded as the last 3 to 5 years, because now they start to see the deadlines arriving. Some companies promise to decarbonize by 25, 30. So it's not going to be only 2050. It's going to be in the next 5 to 7 years. And these projects are happening. Indeed, it is the same principle, but everybody want to see it applied in their industry, in their country. And starting from new construction, as Tom has shown, that's probably the easiest way, because you start from a blank sheet of paper. Converting the existing sites is it's a bigger challenge, but we are also tackling that because we need to decarbonize the existing assets. We cannot just wait for new assets to decarbonize.
My comments on that will be probably not politically correct, but the companies I've seen who are doing this have got rid of their sustainability people who are writing reports for the last 20 years and brought more engineering, practical implementation people in. That's been our experience, you know. So we've gone through a stage where there's been a lot of reporting. We're at a stage now where we need to go through implementation. So it's not the same skill set, and that's what we found. So that's my experience. The most successful companies have said, yeah, we need to change that. And they need to be more engineering rather than report writing. Not politically correct.
Not politically correct, and I would not comment on that one. I think there is an important point also is some people say we need to wait for the grid to become cleaner to install electrification technology. That's not true with heat pumps. When you install heat pumps, even in a country where the grid is not very clean, like the one we are in, you decrease by 3 the impact. So you can get something cleaner than a gas boiler on an efficient gas system installing a heat pump, even with the current grid mix. And obviously, the cleaner the grid will become, these assets will be there, and they will deliver a cleaner heat again. So there is no reason to wait, but we need to go through the diffusion of information to get this innovation going.
And I think I have time for just one more question. And this is more specific, and it's because we spoke about renewable energies, and you already show in your presentation. And I was asking myself, which role do batteries play in terms of circular energy and electrified processes?
From my point of view, it's a very important topic to storage. And battery storage will be one of the part. ENGIE will increase the battery storage capacity in Germany up to 1 terawatt hours. So it's very important in this energy system that we have the storage in the B2C market, the same in the B2B market.
Yeah, and in thermal, actually, it's much cheaper and easier to store heat than to store electricity with lithium battery, etc. So we have thermal batteries, which we used to call hot water tanks. Now we call them thermal batteries. What's also interesting is that for the higher grade heat, the hundreds of degrees of heat, they can be also stored with solid thermal storage or phase change materials. And now we even see a kind of movable version of this solid thermal storage. So Waste heat is going to become a commodity. It will be measured now with the new European directive. People will start to realize that it exists. They might end up paying taxes on it, but it's also a commodity which can be sold from high-grade heat company to the low-grade heat company, and it can be actually even moved around beyond the boundary of a site or just a pipe between two connection sites.
Thank you. Mr. Marren?
Yeah, well, look, I agree with my colleagues here. Look, there's two forms. There's electrical batteries and thermal batteries. Thermal batteries are much, much cheaper. As you said, hot water tanks now are thermal batteries. But there's huge innovation in both. And the great thing about this huge cost reduction in both technologies. So, yeah, but they definitely go hand in hand with circular and decarbonisation.
Well, thank you very much. I don't know if we have just for one question or comment. Someone? No? Okay. Well, in that case, I encourage you to continue the discussion beyond this panel session. It will be good to share experience, to see more steady case studies. And thank you very much for your valuable insights. And it was a pleasure. And I wish you a nice day, a wonderful day. Thank you.